Hello everyone, I'm Robin, CTO here at LoadImpact, and will be presenting and demoing for you today. As Maria said, I'm going to talk about how to integrate load test into an automation pipeline, CI process if you will, and we're going to use Jenkins. And I'm going to do so both for our current Lua-based product and also show how to do the same with K6, our new and open source load testing tool. But before we jump into that, I'd first like to talk briefly about why we decided to build K6. So roughly a year and a half ago, we sat down and discussed our future direction, and we felt that the performance testing was changing. We were seeing more developers using our service, and we heard that many organizations were going through internal changes. They were adopting a DevOps mindset, and as a result of that, performance testing responsibilities were being partially shifted from QA and performance engineers to developers. And at that point, we knew we needed to update our product to adapt to those changes. And we identified a number of important changes that needed to be made in the product to improve the workflow and thus make developers more productive with load testing. And we arrived at these four things as being the most important. And I'm going to go through them quickly now, but we're also going to touch on them a little bit later in the webinar. So the first of these is local execution. And there's actually several benefits with being able to execute a test locally, so generating the traffic from your local computer. But the most important aspect of that is that you get faster, quicker edit, test, debug cycles when you're developing your test cases. The second important thing is that tests are expressed as code. And when I say test here, I mean both the actual logic of the user scenario, but also the configuration. So everything is expressed in code. And we also wanted to take the opportunity to make test cases modular so that you could share code across teams and share code for tests that you run across different environments like staging, production, etc. And also having all the test cases expressed as code makes them very easy to version control. The third important thing we wanted to cover was automation friendliness. So developers love to automate things as much as they can. So when you have a load test, you need to be able to set conditions for when a test has passed or failed if you want to include it in an automation pipeline. So and in K6, you do that through checks and thresholds, and we'll touch upon that a little bit later as well. And the other important thing for a tool is that it needs to be able to signal to the automation tool or the CI tool whether a test has successfully passed or failed. And usually you do that through the exit code of the tool. So that's something that needs to be supported by a tool. And the fourth important thing is actionable results. And this I won't actually go into too much in this webinar as it will be the subject of a future webinar. But it means more or less that developers are a little bit less experienced usually with performance testing compared to QA professionals and performance engineers. So having more direct and actionable results helps developers when they do load testing. So with that said, let's have a look at the similarities and differences also between the Lua-based product and the JavaScript-based K6 tool. So in the Lua-based product, you create your test cases with Lua code, and then everything is kind of centered around the LoadImpact service and the web GUI that we have. So you have your edit, test, and debug cycles all in the web app, and you execute your tests in the LoadImpact cloud, so on servers managed by us. So and you can trigger test runs through the web GUI using our CLI tool, and as well as talking to our REST API more directly. And all the results are stored, and you can view and analyze the results through our web GUI as well. So now if we compare that to the JavaScript-based K6 tool, in K6 you write your test cases in JavaScript instead. You would store your test cases locally, or preferably in a version control system. So for example, in Git or on GitHub. And then the entire kind of edit, test, debug cycle is done locally. So you, excuse me, you can use your favorite editor to create your tests. You can create modular tests by having different files and combining them into more complex scenarios, and then you would use the K6 command line tool to execute the test locally, debug your scripts, and run them again, etc. But you also have the option of running your K6 tests in the LoadImpact cloud on servers managed by us. And the same thing goes for K6 results. So K6 results you can also store either locally, or you can store them in the LoadImpact cloud service. So it gives you more flexibility. So now that we have some background on how the current Lua-based product compares to the JavaScript K6-based product, let's have a look at the workflow for how you would create a Lua-based test today in the web GUI. So it's more or less a three-step process, where the first step is to create a user scenario, which is more or less a Lua script. And there are different ways to arrive at the Lua script. You can either hand code it, but it's more common that you would start off by, for example, doing a recording using our Chrome extension, or by converting a Postman collection using our Postman to Lua conversion tool. And once you have one of our scenarios, you can combine them into a test configuration and select from which regions you want to generate traffic, how much traffic you want to generate, etc. And when you have your test configuration, you can run it, and you can trigger a run in different ways. The easiest is to trigger it from the web GUI itself. So let's now head over to the web GUI and have a look at this workflow. So here I have a very simple Lua user scenario. I've just hand coded it myself. It generates requests against a very simple testing system that we have, and also requests to static resources. So once you have your Lua scenario like this, you would test it out by using the validation function here. So you can run a validation, and a validation is just a simple small load test, one user running through the script once. And then you get your validation results here in the right panel. And we can see in this case that we have a request that failed. We couldn't find a resource. And if we look in the script here, we can see that we forgot a G here on our PNG file. So we edit that and we do another validation run. So it takes some time. We have to wait for the validation service to complete this small test execution. And there we go. This time it's successfully ran. So now we've completed the first step. We have our scenario. So now the second step is to create a test configuration based on this scenario. So go to the tests page here, create new test. We give this test a name. It's called webinar. We add our user scenario that we created. We can select a geographic region here. We're just going to use Ashburn, the default. We're going to create traffic simulation. We're going to say we're going to simulate up to 25 users, and we're going to create a very short test of 1 minute. Save the test. And then the last third step is, now that you have your test configuration, you can run it. So I'm going to trigger run here from the web app. Now we get to the result page, and we're not actually going to stick around and look at the results. We're going to come back to the result a little bit later, but we're instead going to go back to the presentation now. And so if you intend to do any form of automation with your load tests, using the web UI quickly becomes tedious. And so for that use case, we have the LoadImpact CLI instead. And the LoadImpact CLI is written in Python, and it's available through the Python packaging index. So you can use the Python tool pip to install the CLI. So you would type pip install LoadImpact CLI into a command line to install it. And then you would also need access to a version 3 API token that you can get from this URL here, app.loadimpact.com/account/token. And I'm not going to actually run a CLI test here. I'm going to show that later when we integrate our test into an automation pipeline. But this screenshot here shows a little bit what it looks like. So you type LoadImpact test run and then a test ID here, and that triggers a run, and then you would get results streamed to the terminal. The other way that you could trigger a test run when you have a test configuration is by using the API directly. So here is an example in the screenshot here. We have used curl to trigger this post request to the LoadImpact API to start a test run based on an ID here. And oh, by the way, the API token here is not valid anymore, so you cannot copy this API token and create tests under my account. Just so you know. Good. So now let's have a look at the process of steps that we have to go through at a high level to add our test to an automation pipeline. So the first thing that we need is the test configuration, which we've already created. The second step is that we need to run a baseline test. The third is to set up our conditions for pass or fail. And the fourth is to set up notifications so that we get notified when a test has failed, which is the interesting case. And then once we have those, we can actually integrate our test into an automation pipeline to trigger a test run. So the first step we've already completed. We have already created a test in the web app and the web GUI. So the second step is to run a baseline test. And a baseline test is a test you execute to find the normal performance levels of your system. So usually you're using a smaller amount of simulated users that you know that your system can handle, so that you can see the performance levels in terms of, for example, response time that your system is having under normal conditions. And so we'll consider the test we started previously in the web GUI as our baseline test, and we'll use the performance levels of that test as the input for the next step, which is to create thresholds. So thresholds you normally want to set slightly above the response times that you observe during your baseline tests. So you want them to act as guards in your automation pipeline. So if you have a performance regression, the thresholds would be hit, and that would fail the test and fail the pipeline, and you would be notified. So let's now go back to the web GUI here and look at the results. So now we have a result from the test that we triggered before. We scroll down here to the main chart, and we look at the blue graph here, and we can see that it's nice, flat, and stable, which is what we want from a test. So we can see that our system coped with the traffic volumes that we sent at it in a good way, and we can see that the response time here is around 450 milliseconds. So that's going to be our base performance level that we're going to use now when we go and set up thresholds. So we click our way to the configuration page here for our test, and we scroll down to the threshold section here. And we're going to add a threshold for the view load time, and we are specifying the failure criteria here. So the baseline test show that we had a response time around 450 milliseconds. So that's our baseline performance. We're going to set a threshold here for 500 milliseconds. So slightly above our baseline performance. Okay, we're saving that for the automation pipeline for later. So now that we have threshold set up, we should decide how we want to be notified by the CI system when our test fails. And either you might have already set up a mechanism for being notified by your CI system, in which case you can more or less skip this step. But if you haven't, you can use the integrations that we have with Slack, HipChat, or a more generic webhook. So I'm just going to very quickly head back to the web GUI here to go to the integrations menu here in the sidebar. Scroll down and we can find the integrations for those Slack, HipChat, and webhooks here. So I've already gotten a webhook URL here from Slack. So I went to the Slack service and I created an integration. It's called an incoming webhook integration. And then you get this webhook URL that you can paste here in this input field. And just to test and make sure it's working, we can press this button test hook here. And then we can go to the Slack tab here and we can see I just got a notification message sent to my Slack channel. All right. So now we have all the prerequisites completed to add our test to an automation pipeline. But before we head over to Jenkins, which we're going to use for the demonstration, I want to briefly touch on two common types of tests and how often it's suitable to trigger those types of tests. So the first one is when you're testing a smaller components, so say like a microservice or an individual API endpoint, for example. In those cases, usually the tests are quite small, and so they don't take too much time to run, and you can collect quite a lot of samples in a short amount of time. So your results actually contains value, and so those types of tests are possible to run very frequently. So perhaps even on every commit of code to said microservice or API repository. And the other type of test is the more complex one, so the more end-to-end types of tests, which they could be composed of several smaller tests that you've combined into a larger test, but they usually take a longer time to complete every iteration of the scenarios, which means that the test needs to run for a longer period of time to collect enough samples for the results to be valuable. So those types of tests are not really suitable for running on every commit unless you are a little bit sadistic and like having your CI builds take a long time to run, but usually that's not the case. So it's more appropriate to set up some kind of scheduling. So maybe running it, every once a day during the night or something, or once a week, whatever suits your release cycles for those types of tests. But let's head over to Jenkins now, so we can demo how to integrate this Lua-based load test into an automation pipeline. So I'm going to use, I have a locally set up Jenkins installation. It's just running in a Docker container here on my machine. And we're going to use the classic Jenkins UI here to start with. So we're going to create a new job. We're going to call it webinar Lua. It's going to be of the pipeline type. We're not going to do any configuration up here in the top. I can just briefly mention. So here you have build triggers. So as I mentioned, two different types of tests. So for shorter tests, you might want to hook this automation pipeline up to your version control system, so that if you commit or push a commit, that would trigger the automation pipeline to run. And similarly, if you have the more complex, longer end-to-end tests, you might set up a periodic trigger so that the test would be triggered every day or whatever is suitable for your release cycles, etc. Here's the interesting part. So setting up the actual pipeline. So Jenkins has this Groovy-based DSL for specifying specifying the pipeline, so you can set up different steps, etc. So we're going to head over to my editor here and look at the pipeline script I have here. So it's quite simple. We have this agent declaration at the top, which basically it's a way to specify if you have a larger Jenkins installation, you can say that you want to run a pipeline on a specific machine that suits your requirements. But in this case, it's just a simple environment. So we just specify any. We specify an environment variable here that we need because we're going to trigger a test run using the LoadImpact CLI, and the CLI needs access to an API token. So we basically pull in the API token from the Jenkins credential store here. So we have a credential called LoadImpact v3 API token that we just referred to here. And then this is the actual pipeline here. So we have just one stage and one step, which is a shell execution, invoking the LoadImpact CLI and telling it to run a test with a specific ID. And actually, I need to change this, so this is not the correct one. So I'm going to go to the web GUI here, go to tests, click on our webinar test, and up here in the URL bar, you can find the test ID. So I'm just going to copy this, go back to my editor, and replace this ID. And now I'm going to copy the entire pipeline script here, go back to Jenkins, paste that in there, apply, save. And since this is just a demonstration, I'm just going to trigger a build manually here. Here we go, the build is running. Let's go and have a look at the output. So we can see now that Jenkins is running this pipeline. It's executing the only build step that we have, which is to run the load test. So it has invoked the LoadImpact CLI, which is now initializing a test. And as the test is running, the CLI will continuously print. It's going to be roughly every 3 seconds to the terminal here, information of how the test is progressing. So we first get the timestamp. Second column here contains the virtual user, so the number of currently simulated users. We have the throughput expressed as a request per second. And then in the fourth column, we have bandwidth expressed as bytes per second. And then we have in the fifth column, user load time. And we can see here the user load time is hovering around 450 milliseconds roughly, which is what we saw also in our baseline test. So luckily, the system is performing equally well to a couple of minutes ago when we ran the baseline test. So nothing has happened to our testing system here, which is good. And then the last column here, we can see a failure rate, but we don't have any failures, so it looks all good. And I can also mention that if these default metrics being printed here from the CLI, if those are not the ones that you are looking for, you can configure that as part of your LoadImpact CLI invocation, so you can select other metrics that are more interesting for your specific case, if that's the case. So now we see that the CLI has reached 25 users, which is the target level, and now it's just gracefully shutting down here. And the thresholds will be evaluated also, and if a threshold is actually hit, the LoadImpact CLI will exit with the non-zero exit code, signaling to Jenkins that this test has failed. So we'll see what is, okay, so now it's finished successfully. As we can see, the load time here was all around or lower than the threshold that we have set up in the configuration. So this run was successful, and if we go back here to the dashboard, we can see that this run was successful. It took a total of 2 minutes to run this pipeline. So that's it in terms of the pipeline here for the Lua-based tests. Let's go back to the presentation. Yeah, so that concludes the part of this webinar focused on the current Lua-based product. And before we move on to the K6 portion of the presentation and demo, I want to just quickly recap the similarities and differences between the Lua product and our JavaScript-based K6 tool. So as we saw, we write our test cases in Lua code, And then the entire workflow of creating these test cases, debugging them, creating test configs, etc., is done in the web GUI at loadimpact.com. And and all the test runs are also run on cloud servers managed by LoadImpact. And the tests are triggered either through the web GUI or through the CLI tool that we saw here in the Jenkins integration. Or you can call directly to the REST API to trigger test runs. And in terms of the results, they are stored in the cloud at loadimpact.com. Now, if we look at K6 again, so in K6, the test cases are written in JavaScript code. The entire workflow is based on your local setup. So you write your test cases, store them locally, or preferably in your version control system. You debug your tests locally by running K6, go back to your editor, and you can also trigger your actual test runs locally, but also use the LoadImpact cloud for executing on our cloud infrastructure. And results, similar to the execution, you can store your results locally, or you can stream them or store them in the cloud. So with that said, when we set out to build K6, we wanted to support 3 different execution modes. That's local, cloud, and clustered execution. And we wanted the K6 tests to run unmodified across these 3 different execution modes. So, and they're suitable for different use cases. So local execution is great for, when you're in that edit, test, and debug cycle of developing your test cases. It's great to have a local tool to test your scripts. But it can also be very helpful if you're, for example, you need to run your tests on premise or behind firewalls. But you will still have the option. So even though you generate the traffic locally, you still have the option to stream the results to the cloud by just telling K6 that you want to output results to the cloud. Cloud execution, which is running K6 tests similar to how the Lua-based tests are run. You run them on cloud servers managed by LoadImpact, and then the results are stored and presented in the cloud. In Insights is what we call the K6 result experience. And cloud execution is something we are currently internally testing, and will soon start a private beta with some customers to test the cloud execution functionality. And the final execution mode is cluster execution, and cluster execution is local execution, but you execute it on more than one server that you manage. So that could be local servers, servers that you have on premise, or it could be cloud servers that you manage, and you also there have the options to store results locally or in the cloud. But this is a future execution mode that we don't have implemented yet. So let's have a look at the workflow now for creating a K6-based test. So unlike the Lua product, in K6 everything is code. And so both the script logic and the configuration, everything is code. And the reason for that is that we wanted it to test cases, the K6 test cases, to be version control friendly, so that you can track all the changes of your test cases and share them across teams, etc. And given that K6 scripting is done in ES6 JavaScript, we also get the second big difference from the Lua-based product, which is modular test cases, that you can split up your test cases into several different JavaScript files, and then reuse those files across different, more complex test cases. And that could, for example, be that you separate them based on pages. So if you're testing a traditional website, you might have one JavaScript file per page, and then you combine them in different ways to create more complex scenarios and flows. Or it could be, in the API testing case, it could be that you have one file per API endpoint, for example, and then you combine them into a larger, more complex API flow. And these two combined makes the workflow much more flexible, as you can now edit and debug tests using a local K6 in your local environment using your favorite editor. And when you're ready and have the need, you can scale to the cloud service, execute your tests in the cloud, having us manage the servers, and you can stream or upload the results to store them in the cloud service as well. So let's now have a look at the simple K6 script. So this is more or less the K6 version of the Lua test we created earlier. So we have here at the top, we have some import statements to import some functionality that we need in our script. The second part here is the test configuration. And in this configuration, all we have here is the ramping specification, so the traffic simulation. And you can have as many stages in your traffic simulation as you want to, and we have 3 stages here. And they basically say that for 10 seconds, we're going to ramp from 1 user, which is the starting point, up to 25 users. The second stage is going to execute for 10 seconds and stay at the previous reach stage, so 25 users. And then for the remaining 10 seconds or last 10 seconds, we're going to ramp down towards 0 users. So ramp up, stay flat, and ramp down. And the last portion here of the script is the actual logic of the script. So again, we are requesting or sending a request to this simple testing system. We're getting back some HTML. I've added two checks here. And checks is a mechanism in K6 script that you can use to evaluate Boolean conditions, and they are similar to asserts in other types of testing frameworks, but they're a little bit different, because an assert in a traditional, for example, unit testing framework would halt the execution when you reach an assert that fails. But in K6, a failure, an evaluated failure is just being recorded and saved, but the execution is not being halted. So here I have 2 asserts, one that looks at the response code and makes sure that it's 200 code. And I also have a check that looks in the body of the response for a specific string. So I'm expecting this string to be present here in the HTML returned by this request. And then down here I have a batch request. So I'm requesting 2 static resources, and they're going to be fetched in parallel. Right, so now we have our script, and so the second step here is to create a test configuration. But you know, in K6, it's one and the same thing. So we've already done that. So the configuration is already done a part of our script. So it's not as it is in the Lua product, where you have first a user scenario that you then put in a test configuration. Everything in K6 is just in the same piece of code. So we've already done this step. The next step is to actually execute this test. Let's go to the command line. So I have K6 installed on my system, so I have it readily available as K6 here. And to run our script, we just type K6 run, and then it's called script.js. And when we run this, we can see here initially K6 outputs the execution modes. Right now we're running in the local execution mode, which means that we are generating the traffic from my machine. We are seeing that the output is the default, which is to send the output to the terminal. So it's going to be a summary output here that we're going to see soon. And we're also seeing that the script, this is the main script, the entry point of our test is script.js. And we can see that the max users that are going to be simulated is 25 users. So there we go, 30 seconds passed, so our test is finished. We can see here in the output that we have green check marks next to our checks. So that means our checks were evaluated successfully on every evaluation. And then down here we get a summary output of the test results. So we get some information regarding the data sent and received. We get information regarding the response time. So the rec duration here is the total response time of the request, and then we have it also broken down into, for example, connecting here, which is the TCP connection time. We have receiving time, waiting time, which is time to first byte, etc., etc. So K6, as I said, K6, when you're running K6 tests like this, you can choose where you get your output. So we can also very easily say that we want to get the output sent to the cloud. So then we add this output option and specify cloud. And for K6 to be able to communicate with the cloud, we have to set up access to an API token. So I previously set up an environment variable, which is called K6 underscore cloud underscore token, which has the value of my version 3 API token. So it's already available here. So if I execute this now, we can see that now the execution mode is still local. So the test is being run on my machine. So the traffic is being generated, the requests are being generated from my machine towards this target system. But here we can see the output has now changed. So the output now says cloud, and we get this handy URL here. So if we go back to our web GUI and paste this URL up here in the URL bar on the browser, we can see that the results are being streamed. Now it's actually just finished, but the results are streamed to the cloud service, and we can now see the results here in Insights, as we call it. And up here we have an overview where you can see the ramp up of the virtual users. You can see the response time, and you can see the test-wide request rates, how many requests are being generated per second. We can see we have no threshold set up yet. We have 2 checks, they both pass. And we can see that the 3 URLs that we're requesting are always returning successful response status codes. And if we scroll down here to the breakdown, we can also see that everything is green here. So that means our requests are generating 100%, successful requests. We can see that our checks have been continuously evaluated positively, so true, throughout the test. And we can also go here to the URL side of things and look at the individual URLs and what their different response times are like. Good, let's head back to the presentation now. So that was executing K6 test locally, and then we also ran it but output the results to the cloud service so that we could graphically do a result analysis in the cloud. The second execution mode is cloud execution, but I'm not going to go into that now because that's going to be the subject of our next webinar. So please keep an eye out for the invitation for that webinar. We will cover the cloud execution aspects of K6. So let's instead go through the steps of how to add this K6 test to an automation pipeline in Jenkins. And it's going to be the same steps as we went through for the Lua-based test. So first we need a test configuration. So we have our K6 script, which is both the logic and the configuration in one. And then we need to run a baseline test, which we have already done now. We need to set up our pass and fail criteria, so our thresholds. And we need to set up our notifications so that we get notified if things fail. And then we can actually integrate the execution of the test into an automation pipeline. So it's the same. The objective with the baseline test is the same. We want to make sure that we have an understanding of the normal performance level of the system that we are testing. And we already did this and we ran it locally, but you can of course use the cloud execution to find these things out, but that's going to be the subject of the next webinar, as I said. So the next step is to set up the thresholds. So we're going to go back to our editor now. And I can say again, so the goal between these 3 different execution modes that we want to support with K6 is that you should be able to run your K6 tests unmodified. So if you create a K6 test and it runs well locally, it will run also unmodified in the cloud and on clustered execution modes. So now we're going to add thresholds here. So it's up here in the configuration or options section. So specify thresholds. And you can add as many thresholds as you need. And the threshold is basically you set specific threshold values for different metrics. So we need a metric here. So we're going to quickly head over to the terminal again. and look at the output here. So these are metric names here. So we're going to pick this one here, HTTP rec duration. Go back to the editor, paste it in here, and then create a list of actual thresholds. We're going to say that we want the average to be below 100 milliseconds, but we want the 95th percentile to stay below 150 milliseconds. So now we have our thresholds defined here in the script itself. And then we go to the command line and we run this again. Run script.js. So I'm just gonna, this is running again. So local execution. I'm not gonna stream it to the cloud this time, so it's gonna be just local output. It's gonna run for 30 seconds. It's gonna evaluate the thresholds continuously, but it's the final evaluation at the end that's gonna matter for what we see in the output. And it's also important to say that similar to the LoadImpact CLI, if K6 threshold is hit, K6 will exit with a non-zero exit code. So if you run K6 in a CI environment, it would signal to the CI tool that if a test fails, it would signal back, and the CI tool would fail that particular stage of the pipeline. So here we can see now we get a green check mark next to our metric name here, which signals that our threshold set up for this metric all passed, and we can see that we are, well below in terms of response times compared to the thresholds that we set up. So that's all good. So let's head back now to the presentation. Right. So once you have your threshold set up, it's we need to add notifications, and again, if you already have a mechanism in your CI setup to get notified, you can skip this step. But if you want to be notified through the LoadImpact system, then you need to make sure that the K6 test is either, if it's run locally, it needs to either stream results to the cloud. But if you're running using cloud execution, then we also get data that we can act on. But if you're just running locally and you're storing results locally, we don't know of the execution, so we can't send notifications. Good. So now we have all the prerequisites completed for our K6 test. So now we can actually integrate the K6 test into our CI automation pipeline. And again, we're going to use Jenkins, but we're going to use it in a slightly different way this time. So now we're going to use the alternative Jenkins UI called Blue Ocean, which is a little bit simpler when you're setting up a pipeline, especially of this kind that we're going to set up now. And it's also a little bit nicer to look at least in my opinion. So let's go here and create a new pipeline. Now you're getting asked where your code is located. So I've created a small repository here on GitHub. It's a public repository. It's under the LoadImpact organization. It contains the script we just created in our editor, and it also contains this file called Jenkins file. And the Jenkins file is a file that Jenkins will recognize when it clones this repository, and it contains the pipeline specification. And this pipeline specification is very it's similar to the one we had for the Lua-based test, in that we just specify an environment variable that's needed by K6 if it's supposed to talk to the cloud, which we want in this case because we want to be notified. So again, we're just pulling in the credential here from the Jenkins credential store. I can briefly just show that. So we have a tab here. So in the Jenkins credential store, I have this LoadImpact v3 API token here created. And then the actual pipeline specification contains, again, just one stage, one step. It's a shell execution, executing K6, executing the script that's in this repository, and we're telling K6 to stream the results or upload the results to the cloud as the test is running. So going back to Jenkins here now, we specify that our code is in GitHub. It's in the LoadImpact organization. And we search for the repository here, webinar. create pipeline. So now Jenkins is cloning the repository. It will find the Jenkins file and it will automatically trigger like a first run of the pipeline. So let's go into this pipeline. And we can see it's already triggering the K6 test run. So we get some output here. It's not super pretty here in Jenkins. But we can see that the execution mode is still local. We are outputting the results to the cloud. We get this URL so that we can go to the cloud service and look at the results if we want. And we're executing tests for 30 seconds. So there's a few seconds left here. And again, so K6, if K6 determines that the execution is successful, it will just return a 0, which will indicate a successful pipeline stage. So that's why we get all the green here. So again, if we expand the output here, we can see that for our the metric that we set up thresholds for, we can see that we get this check mark here. So everything was fine. But in the event that the K6 or the thresholds would have been triggered, K6 would have exited with a non-zero exit code, which would have signaled to Jenkins that, hey, this test failed, we should fail this pipeline. So there we go. Now we have run a successful run of our K6-based pipeline in Jenkins. So let's go back to the presentation. So that was it for the K6 portion. So now we've both integrated a Lua-based test into an automation pipeline in Jenkins, and as well as having done the same for K6. So briefly to recap here the differences and similarities between the two products. So the Lua-based product, we create the test cases in Lua. And the entire workflow is around the web GUI at LoadImpact.com, and tests are run in the cloud. You can trigger the test through the web GUI, the CLI tool, or our REST API, and the results are stored, viewed, and analyzed in the cloud through LoadImpact.com. And for K6, you write your test cases in JavaScript instead. You store your test cases locally in a version control system, preferably, and everything is centered around your local environment. So you can use your favorite editor. You have access to the load testing software locally. So you use K6 locally to execute your tests and debug them. You can run your tests locally or in a CI tool or on premise, and then you can decide to scale up and run tests using the cloud execution mode on LoadImpact managed cloud infrastructure to spread it geographically and run larger tests. And you can also choose whether you want to store the results locally or at LoadImpact.com. So the experience is more flexible in those two aspects, execution and result storage, than the Lua product. So with that, I want to thank all of you for listening and viewing this presentation and demonstration.